In this video, we're talking about Boolean expressions. A Boolean expression is a combination of variables, literals, arithmetic operators, relational operators, and logical operators. It's an expression that always has a true or false result. Boolean expressions are a really important topic because they are the building blocks that are going to allow us to make decisions in our programs with things like if statements. They're also what's going to allow us to control loops so that we can repeat algorithms within our computer programs. And so it's really important to spend some time this week practicing both building Boolean expressions and also evaluating Boolean expressions to make sure that you understand this important building block. Let's look at all the different components of the Boolean expression. So they can include variables. We're experts on those. That's a named storage location that we can use to store data in our program. Just like arithmetic expressions, Boolean expressions can also include literal values, which are values that are literally typed into your program, like the number 2 or a character B. It's anything that you physically type into the program. Arithmetic operators we talked about last week when we built arithmetic expressions. Those are multiplication, division, the integer remainder operator called modulus, addition, and subtraction. And Boolean expressions add two additional kinds of operators, relational operators and logical operators. We'll be reviewing those items today. Remember, anytime you're building a Boolean expression, it's always going to give you a true or false result. And that's what allows it to help us make those decisions in our programs and also to build loops. Let's look at a couple examples of Boolean expressions just written in English. This first one has a Boolean expression at the end. The Boolean expressions are identified with bold text, asking us, is our course average at least 93%? So that's a Boolean expression. It's going to have a true or false answer. Either your average is at least 93% or it isn't. So the answer is going to be true or false there. And you can see in our statement, it's helping us make a decision about what our current course grade is. Today, we're just focused on the Boolean expression parts, and then we'll learn about the decision-making step later this week. Let's look at the second example. You have Wi-Fi or you have textbooks. Again, that's a expression that's going to have a true or false result. Either you do have Wi-Fi or you do have textbooks or you don't have either. And then finally, this last expression, we're asking, do you live within 120 miles of UMW and do you have a car? So again, that's going to have a true or false answer. Either you have both of those things or you don't. Let's learn about translating those English ideas into Java syntax. We said one of the additional components that a Boolean expression can have is that it might include a logical operator. There are three logical operators, and those are and, or, and not. Some programming languages allow you to write out the word and or not in the syntax, but Java uses special symbols for those ideas instead. So the two ampersands means and, the two bars, or sometimes those are called pipes, those mean or, and the exclamation point means not. Whenever you're typing in the two ampersands, it's just the ampersand sign typed twice, and that's on the top row of your keyboard above the numbers. The pipe symbol is usually over on the right-hand side of your keyboard, somewhere above the enter or return key. And you usually have to press shift down to get that value to print into the syntax. And then finally, the exclamation point, that's in the top row of the keys as well, above the numbers. When we're thinking about how to evaluate the expressions and or not in our programs, the good news is that the normal rules that you apply to those items just in English sentences also apply in a computer program. So the and gives a true result if both of the operands are true. Let's look at that with our previous example where we were writing about various scenarios in English. So we had one expression up there that included and. You live within 120 miles of UMW and you have a car. And so you already know how to evaluate that. Suppose that I live 500 miles away and I have a car. Would it be feasible for me to go home over the weekend? That would be no, because I don't live within 120 miles of the university. That's going to preclude me from going home frequently. Similarly, if I live 10 miles from campus, but I don't have a car, I'm still not going to be able to go home for the weekend frequently because I don't have a car. The second part of that condition isn't true. It's only if both conditions are true, if I live within 120 miles and I have a car, if both of those are true, then the answer to the condition is true. So again, with and, the result is true only if both operands, both of the things that you're considering, are true. Let's look at the or operation. It's true if at least one of the operands is true. Let's look at the example in English up at the top. So suppose I'm deciding whether to study at home. Suppose that decision is based on whether I have Wi-Fi at home or if I have textbooks. So if either of those is true, I'm able to study at home. So suppose that I have Wi-Fi, but I don't have any textbooks. Can I study at home? Sure, because I do have Wi-Fi, I'm going to be able to get access to all of my electronic items. Suppose I don't have Wi-Fi at home, but I have textbooks. That also allows me to study at home because I could study using my textbooks. Finally, suppose that I have both. Suppose that I have Wi-Fi at home and I have textbooks. That still allows me to study at home because both of those expressions are true. The only time I can't study at home is if I don't have Wi-Fi and I also have textbooks. That leaves me with nothing to do while I'm at home. So the result is true if at least one of the operands is true. Another way of saying that is that it's false only if both operands are false. Finally, let's look at the not operation. The not operation is true if the operand is false. In other words, the not operation kind of just flips the value of the expression. If the expression's value is true, then putting a not in front of it will make it false. And if the result of the expression is false and we put a not in front of it, it will make it true. It's kind of like saying, is it raining? Right now it's not raining, so my answer would be false. But if I ask, is it not raining? Then the answer is true. So it's just taking the inverse value of the expression. Logical expressions or Boolean expressions can also include relational operators. Let's look at those. Java has two kinds of data types, primitive types and reference types, and they use different kinds of relational operators. We're primarily focused on primitive types at this point in the course. Can you remember what some of the primitive types are? Some examples of primitive types are integer, double, character for a single character, and Boolean for a true false value. All of the primitive types can use the relational operators less than or equal to, greater than or equal to, not equal to, which is the not symbol with a equal sign, and then the equality test, which tests to see if two values are identical, and the equality test is two equal signs right next to each other. Later this semester, we're going to talk about reference types and how to make comparisons with them. They use special operators like an equals method and a compare to method that allow us to compare things that are reference types. One kind of reference type is a string, and we're going to spend a whole day talking about strings in a future lecture. Just as a quick preview of what the relational operators look like with strings, I put some examples in our notes for today, just so when you go back and review them, you remember these differences that apply to strings. But again, we'll talk about them in more detail in the future. The equals method can be used to compare two strings, and it returns true if the first string, the one right here before the period, is identical to the second string, the one that's in the parentheses here. The two strings are different, then this expression or method equals returns false. There's also a method that allows us to duplicate the behavior of less than and greater than operations using strings, and that method's called compare to. It returns a value that's either positive, zero, or negative, and the result indicates the order in which the two strings, first string and second string, should be ordered alphabetically. If the two strings are identical, then the compare to method returns zero. If the first string should come before the second string lexicographically, then the compare to method returns a negative number. Lexicographically is a big fancy word that just means alphabetically, but also case sensitive wise, where the uppercase or lowercase letters are considered to be before the other version of the letters. I always have to look up which version of the letter comes first, and it's that the uppercase letters come before the lowercase letters, so uppercase Z comes before lowercase a. And finally, if the first string comes after the second string lexicographically, then the compare to method will return a positive value. Again, we're going to review the equals method and compare to methods in a future lecture dedicated to strings. For now, let's move on and look at the order of operations. So we just introduced some new operators, the various logical operators and, or, and not, and also the relational operators less than or equal to, greater than or equal to, not equal to, and the equality test. Those are all included in the order of operations in this chart here in your lecture notes. You can see that the not operator has the highest level of precedence along with the positive and negative operators that can make a number positive or negative. The next highest order of operations is multiplication, division, and the integer remainder, the modulus operator. Then we have addition and subtraction. Following that, we have all of the relational operators that include less than or greater than. Then we have the equality test and the not equal to operator. Following that, we have the and operator, then the or operator, and then the assignment operator. You probably haven't spent a lot of time in the past including all of those operations in your view of order of operations. So this might be something that's worth putting on your reference card for upcoming exams. That way you know exactly what order to apply the various operators in any questions that you encounter. Speaking of example questions, let's do a few examples right now. In your notes, there's some example variables with assigned values. So we have a integer variable x and it's storing a 4, an integer variable y and it's storing a 6. We have a string value that's storing the phrase CPSC 220. And finally, we have a Boolean variable result, which we're going to use to capture the result of various Boolean expressions. Let's evaluate this first expression together. So the expression is result gets not the quantity x plus 2 is less than y. So I'm going to scroll back up so I can see my order of operations. I know that the assignment operator, that's the last thing that happens. So I'm just going to copy that down. And then the first step that I always do is fill in the actual data value stored in memory for all of these variables that are included in my expression. So the value of x is 4, I'm going to type that in, and the value of y is 6. So next, I'm going to figure out what operation to perform next using the order of operations. I should do the part that's inside the parentheses. So I'm going to turn my attention to that, ignore the not for a minute. Just copied that down. And then I need to think about which has precedence, the addition symbol or the less than symbol. So looking at the order of operations, it's the addition symbol. So I'm going to do the 4 plus 2 next. That's 6. And now I'm going to continue on. I'm turning my attention to the part that's in parentheses. Parentheses always has priority. So I'm asking myself, is 6 less than 6? That would be false. 6 isn't less than 6, it's equal to it. And then finally, I'm ready to apply my not operator to that expression. It just reverses the value. So because the value is false, putting not in front of it means the final answer is true. So the value that gets stored in my variable result after this expression would be true. Now is a great time to pause the video, evaluate these next two expressions on your own, and then when you're done evaluating them, come back to check your answers. Evaluating this second expression, I'm going to start in the same way where I fill in the actual data value from memory for all of my different variables. So I'm just filling in the y's as 6 and the x as 4. And then I'm going to ask myself what expression should be evaluated next. So it would be the most nested level of parentheses. That's the 4 plus 1. Awesome. At this point, the parenthesis levels are the same. So I'm going to evaluate this first set of parentheses first and ask myself, is 4 not equal to 6? That is true. 4 and 6 are not the same. Copying down my work from the previous line. Now I'm ready to evaluate the second expression. Is 6 equal to or the same as 5? No, those are not the same. So my second expression is going to be false. And then finally, I'm joining together my ideas of true and false. Remember, and is only true if both operands are true. And since my second operand is false, that makes my expression false. So the second expression is going to store the value false in my variable result. In this next expression, things kind of start out the same way, copying down my expressions. So first I'm evaluating the 4 plus 1, that's 5. Now I'm going to evaluate my left expression, 4 not equal to 6. That's true. 4 is not equal to 6. And then I'm going to evaluate my second expression. Is 6 the same as 5? That's false. And now I'm joining those two sub-results together using the OR operator. Remember that OR is true if either or both operands are true. So in this expression, the final answer will be true. That's what's stored in my variable result. Remember that if you need to do some more practice with those kinds of expressions, you can always ask AI to generate some additional examples for you. You can just copy and paste out of the class notes and say, these are the examples we did in class. Could you create some additional expressions that have the same difficulty level? And AI will be able to do that well. Let's look at these final two expressions. These include the string comparison operators that we use with reference types. The first operation here is the equals operation. So it's asking whether our string name, which stores CPSC 220, is equal to or exactly the same as the string CPSC 110. And hopefully it's obvious that those are not the same values. That's going to return a false response. Let's look at another example. This one's using the compare to operator that compares two strings lexicographically. This time it's comparing the contents of the string name, that's CPSC 220, and it's comparing it to the string CPSC 220. Whenever the compare to operator compares two data values and finds that they're identical, it returns a value 0. So the result of this first expression here is going to be 0. And then we're checking to see, is that result greater than or equal to 0? And that expression is going to be true. 0 is greater than or equal to 0. So the value that gets stored in the variable result is true. It's not essential to do additional practice with the string operators at this time. Again, we're going to have a future lecture that focuses exclusively on string operations, different methods that are available to us in the Java standard library.